today's webinar. Just want to make sure everyone, you can hear me okay? There's no issues with the audio or anything like that? Okay, awesome. So today we are covering good old work questions. We did do rates last week, which by rates I mean distance questions. So, the nice thing is that there are lots and lots of similarities between these two types of questions. So if you can be super systematic with your approach and how you're dealing with them, just like rates, you can be really, really successful with work problems. Now, there are different ways to deal with work questions. With that said, I like to use something called combined work. You will probably see things like combined rate as another way to kind of deal with these guys. I'm okay with, you selecting something that works well for you and going with it, but obviously I'm going to show you kind of my method today. So what we're going to do is go to about quarter of and do a lot of really high impact stuff with work, and we'll see how far we can get and then kind of go from there. So let me just get the first question up and then you guys can have at it. And as always, put your answer in the chat box so we know what you're getting and stuff like that. So give me one moment to get the first problem. There you go here. And obviously everyone, when you're done with the webinar, feel free to kind of take what we've learned here and then reapply it back to what you're doing in your own studying. So if you've hit the work chapter already, and let's say maybe you're having an issue or two with it, it would be advantageous for you to go ahead and practice some of the skills we're talking about. These are skills that mimic, what we teach in the chapter, but I do think that, you can be pretty successful, following these skills. And remember, it's all about pattern recognition in these questions. So, the first thing you always want to do is you want to make sure, A, you're able to look at what the problem is asking, and then B, fully recognize a process with it. So if you remember last week with distance questions, we did things like average rate, we did things like converging problems. So the idea was to fully notice, okay, this is the type of problem that's in front of me, and this is the formula I need to use it. Now, I'm not saying that every single problem like that is going to allow you to say, yes, I have to use, formula X, formula Y, or formula Z. But for those that do, it would make sense to use that, use that process. Now, I'm just having a little bit of technical difficulties here. So, to these problems, so give me one more second. Okay, so just getting rid of a few things here. Okay, so the first one is going to be a pretty, I'd say a pretty basic problem, something that you're probably used to just from doing work problems in general. But the idea here is to really get a feel for kind of the process that we like to use as far as solving general work questions. So I'm going to give everyone this problem to start. And as I said, I'll give everyone about 2 minutes, and then we can go from there. Okay, so it's about 2 minutes there. So as I said, this is a pretty basic work question. As we showed last week, we do like using the chart for rates. I do also like using the chart for work. Now, as I tell my students, the chart isn't to change what the math is in the question. The chart is to organize your information. So if you're someone who doesn't like to use a chart, but yet you feel like you can stay plenty organized, no worries. You don't have to use it. It's just something that we use to create a systematic flow when you're dealing with these questions. So as you can see in this question, we're given the rate of X, and keep in mind, when it says X can fill a pool in 6 hours, that's not the time, that's the rate. So it's one job per 6 hours. And then Y can fill the pool in 8 hours, one job per 8 hours. Now, we also know that they're working together. So it's T and it's T, meaning the time is the same for both of them because they're working together. We multiply across, we have 1/6T and then 1/8T. Now, the formula that I use is work of one worker plus work of a second worker equals total work. Now, in this case, total work is 3/4 because the job has not been completed. We're only doing 75% of the pool. So we say 1/6T plus 1/8T equals 3/4. We multiply everything here to get rid of the fractions. So we multiply by 24, giving us 4T plus 3T equals 24/18. So we end up getting 7T equals 18. T equals 18/7, which is 2 and change basically, or 2 3/7. So we see the answer is 3 hours. Another important component of this question is you'll notice that the answer choices are somewhat, they're not exact. Less than 3 hours, between 3 and 4 hours, between 4 and 5 hours. That's really important because if you're doing this problem and you think something isn't working out the way it needs to, like let's say you think that your answer should be cleaner and that worries you, you're in a position where you may go back and try to fix mistakes that don't really need to be fixed. So with that said, put yourself in a position where you are actively trying to look at the answer choices, at least to have them somewhat analyzed prior to jumping into the question itself. So something to think about, and something that will really help you, because then you're not going to waste time thinking that you screwed something up when in fact you didn't. So what I want to do next is I want to do some variations of these problems, and take a look at this here. Okay, so that's about 2 minutes there. So another good problem. This is definitely a variation of what you just saw. So what we have here is two machines or two machines, machine A, machine B, and we have a rate, we have a time, and we have a work. Now machine A's rate is 1 over 2. Machine B's rate is 1 over 3. And they're working for 3 hours to build the same car. Now they work for 1 hour together, or excuse me, machine B works, that's machine B's rate. So that's actually not them working together. But they work for 1 hour. Since machine B breaks down, machine A has to finish. So there's two ways to look at this question. Way one is figure out how much work was done in the hour, determine how much work is left to be done, and how long it'll take machine A. I think a better way to do it is to put a plus X, put that over 2, make this a 1/3, and then systematically still use the good old combined work formula. Because the job is being done, you set it equal to 1. You multiply by 6 to get rid of your denominators. You get 3 plus 3x plus 2 equals 6. 3x equals 1. X is 1 over 3. And that's, of course, 20 minutes. So again, I say this every time we meet and every webinar, being systematic is key. You don't need to necessarily be a math genius to master this stuff, because I myself was a history major, so there you go. You need to have a process. You really, really do. There are people who can get around not having a process, and I understand that. But for most of the students out there that are struggling with the test, you want to have a process and lead them. So here is going to be another variation of what we just did, and then I want to kind of talk about all this full circle before moving to the next question. So I'll give everyone a few minutes here. Okay, so that was about 2 minutes there. So this is a really good question again because it's another variation to what you already saw. So, and again, if you use combined rate here instead of combined work, it's not the end of the world. Again, you just want to make sure you have a process and a process that works. So we have rate time work. We have Carla. We have Dan. Now Carla's rate is 1/42. Dan's rate is unknown because it doesn't give us his rate. Not to mention, it says how long would it take Dan to load the dishes by himself. So one of the mistakes that people make is instead of putting 1/x, they like to put x. Remember, your rates have to match. So Carla's rate is 1 job in 42 minutes. Dan's rate has to be 1 job in X minutes. So just keep that in the back of your mind. We have 28 minutes for them to work together to wash the dishes. So we have 28/42 and 28/x. So again, staying systematic, work of one person plus work of the second person equals 1 because the job is complete. Always simplify your fractions. 28/42 is equivalent to 2/3. So we have 2/3 plus 28/x equals 1. Multiply everything by 3x. 2x plus 28 times 3, and I was going to do it in my head, but I won't. That's 84. Equals 3x. 84 equals x. So if you were to plug this in here, Dan's rate is 1/84. So the answer is D. So here's what I want everyone to see here. I want everyone to see that, look, we used work of one person plus work of a second person equals total work here. We also did it here, and we also did it here. So the cool thing about this formula is that it works in many, many places. When I was a GMAT student, what used to screw me up, especially with distance and rate problems, is that I was always grasping at straws when I came to a particular place where I had these types of questions because I never had a firm grasp of how to deal with it. Sure, if you have 10 minutes, you can finagle your way to an answer, but you don't have 10 minutes. You barely have 2 minutes depending on how the test is going. So I like this over anything I've done, and because I'm not a math genius, and because I need a systematic approach, because I feel like I can read, analyze, and attack in very short order. Now we're going to do some other types similar to this, but so far, hopefully, everyone is seeing the process, and with that in mind, I want to do another one, although this is going to be slightly different. So let's take a look at this here. I'll give everyone about 2 minutes. Okay, that was about 2 minutes again. So this question is really not all that much different from some things we were doing previously. The only real difference here is that instead of the works being added together, the works are being subtracted. So this is what we call opposing work. You can think of it like a push and a pull. The GMAT loves to set this up using faucets and drains, because what does a faucet do? It fills. What does a drain do? It empties. So when you combine those, it's kind of opposite forces happening at once. Thus, there's no way we can add together the work of the drain and the work of the faucet, but rather we're subtracting. Now, the way that you subtract is you take the thing that's doing more work and you subtract it from the thing that's doing less work. So keep that in mind as we get through the question. You want to use your chart. You still set it up. And we have rate time work. We have a faucet. We have a drain. The faucet can fill an empty tank in 20 minutes. That's 1 over 20. The drain can empty the tank in 36 minutes. So just to be clear, the thing that is faster is the faucet because it's doing its job in 20 minutes, whereas the drain is doing its job in 36 minutes. So something to think about so you're not getting that backwards. Now, since this problem revolves around a faucet filling a tank with the drain open until we get the tank full to the top, that means these actions are happening simultaneously, which means they're working together for the same amount of time. So we have 1 over 20t, we have 1 over 36t, and basically we can take this, and we can subtract. Now, as I said, the faucet did more work, so it's 1 over 20t minus 1 over 36t equals a complete job. Now here's where things get a little interesting, and this has less to do with work questions and more to do with fractions and least common multiple. I personally love to get rid of fractions by multiplying through the least common multiple. Even if you have to add fractions together, the reality is you do need to come up with an LCM here, or excuse me, an LCD, least common denominator. If you're struggling how to do that, in this particular case, because you're dealing with slightly large numbers, there's a couple methods you can use. Now, you could break into primes. I mean, that is the most systematic way, and then just get the LCM. You know, or you can always eyeball the values. Now, if we break this into primes, you get 2 to the 2, 3 to the 1, 3 to the 2, 2 to the 2. So as you know, to get an LCM here, we're going to take 2 to the 2, and we're going to multiply it by, I'm sorry, whoa, screw that up. 20 is 5 to the 1, sorry. We're going to take 2 to the 2, 3 to the 2, and 5 to the 1 here. And that's super important because this is what the LCD or LCM would be. And you see we end up getting 180. So now we have the opportunity to multiply through. So we have 9t minus 5t equals 180. 4t equals 180. And finally, t equals 45 minutes. Answer E. So again, 4 problems, 4 similar processes. I'm hoping we're all on board with that and feeling good about it. But, you know, I think that when you're said and done with these problems, they should end up being your bread and butter. We want all these tools to certainly be in your toolbox. Now, to flip the script a little bit, we're going to actually throw some percentages in. And as anyone knows on the GMAT, what makes the GMAT hard is they take different topics and throw them at you in different ways. So here is a fantastic example of that. So I'll give everyone a minute or 2, and then we can talk about this problem. Okay, so that was about 2 minutes there. So this is a very, very interesting question because where I find a lot of my students go wrong is they try to actually use algebra here. And for anyone who's attended my past webinars, when we've done ratios, I'm doing percents, and I feel like I've said this a lot, you're in a position where when the answer choices are in percentage form or ratio form or fraction form, you're not really ever performing algebra, which is why the idea of a smart number exists. Not saying we have to use a smart number here, but that's the reason why. That's why you can just plug in a random number. When you have to perform algebra, that's 100% not the case. So here we have our three machines all doing something together. So rather than even doing the combined work formula, we are doing rate time work, machine A, machine B, and machine C. Machine A can do the job in 8 hours, so the rate is 1 over 8. B is 4 hours, that's 1 over 4. C is 4 hours, that's 1 over 4. If all machines work together, so what I would do is I would just say, hey, they're working for T, T, and T, so that's the same time for all of them. So now when I'm getting total work, I'm not saying total work is 1 and actually solving for T. I'm literally just adding these together. So we'll notice that the common denominator is 8. That's 2 HT, 2 HT, so that is 5 HT. And then it's the work of machine A. You'll see machine A does 1 HT work. Cancel, cancel. We get 1 over 8 times 8 over 5. Cancel, cancel, 1/5, 20%. So don't do algebra on these percent questions. You don't need to, and you will be very, very, very successful. So I want to do one more type of problem, and then we can call it a day, and we'll be off until next week. So everyone take a look at this here. Give everyone about 2 minutes. Okay, that's about 2 minutes there. So this is an interesting question because what's going on here is we're going to use a combined work formula, but what I'm going to do with these rates is I'm not going to be making them fractional rates. And the reason for that is because you see that the rate given in the problem is 60 fish per hour, which is 60 over 1. So it's not a fractional rate situation. So to start, we have Joe and Mark. Joe catches 4 times as fast as Mark. And we see that in 1 hour, which is the time, they do 60 fish, or catch 60 fish. So doing the math here, we get X is 12. Now we can fill that back in, and we would say 4X is 48, and we would say X here is simply 12. Now here's the kicker. If Mark starts catching fish as fast as Joe, we have 48 plus 48 because they're both working at a rate of 48 fish per hour. How much would they catch in 2 hours? That becomes 96 times 2, which is 192 fish. So this is a similar type of problem, slight differences, still using combined work, which really is how we did every problem today. So hopefully this gave everyone a good idea of work questions. If you're using our course, go back, pound away at this stuff. I know you all can master it. I'm confident in that, and I know the material is there that you all need. And until then, thank you everyone for coming, and we will see each other next week. So I'll talk to you soon.